Although soil is common and insignificant in our lives, it has a great impact on buildings. Next, we start with the finest soil to learn the relative properties of foundation and substructure. The main task of this section is to master the origin and composition of soil. We will explain it from three aspects: the origin, classification, and composition of soil. 1. Origin of soil. Soil is a particle of continuous and solid rock of different sizes formed by weathering. After different transportation methods, sediments are generated in various natural environments. Soil consists of solid particles, water, and gas. 1. Geological processes. The Earth's crust is constantly changing, and the effect that causes the constant change of the surface morphology of the Earth's crust is geological process. Geological processes can be divided into internal force action and external force action according to energy. Internal force. Energy comes from the heat. Energy inside the Earth, which is manifested in crustal movement and magmatic activity, such as earthquakes, volcanic eruptions, etc. External force. Energy comes from the outside of the Earth, mainly solar energy, and manifests itself as weathering, erosion, transport, deposition, and consolidation into diagenesis. 2. Weathering. Soil is a weathered material of the surface rocks that remains in place after continuous disintegration, breakage, and chemical destruction. Under the geological process, especially the weathering, after various erosion and destruction processes, namely wind action, fluvial action, and biological activities, it has been formed to be loose accumulations, namely residual deposits and sediments. Weathering can be divided into physical weathering, chemical weathering, and biological weathering. 2. Classification of soil. According to the genetic conditions, soil is mainly divided into residual soil, slope soil, diluvial soil, and alluvial soil. From the pictures, we can get a brief understanding of several kinds of soil. 3. Composition of soil. The composition of soil mainly refers to the three-phase composition of soil. That is, soil is composed of three parts: solid particles, solid phase, water, liquid phase, and gas, gas phase. 1. Solid particles in soil. The shape, size, mineral composition, and composition of solid particles in soil are the main factors that dictate the soil physical and mechanical properties. The mineral components of soil particles include primary minerals and secondary minerals, having different effects on soil. The size of solid particles in soil is usually expressed by its diameter, referred to as particle size for short, with the unit being millimeters. In order to facilitate the study, the particle size of soil is divided into one group according to the principle of similar properties, which is called particle group. The engineering properties of soil in each particle group are similar. The commonly used division of soil particle groups divide soil into 6 particle groups according to the boundary particle sizes of 200 millimeters, 6 millimeters, 2 millimeters, 0.075 millimeters, and 0.005 millimeters. 2. Particle gradation of soil. Particle size gradation. The relative content of each particle group is usually expressed as a mass percentage. Determination method. It is determined by sieve analysis, which is suitable for soil with particle size of 0.074 mm to 60 mm. Expression method. The gradation curve is used for expression. In the figure, the abscissa uses logarithmic coordinates to represent the particle size, and the ordinate represents the percentage content of soil particles smaller than a certain particle size. If the curve is steep, it means that the particle size range is smaller, and the soil particles are more uniform. On the contrary, it means that the particle size is largely different, and the soil particles are uneven. That is, it's well graded to quantitatively reflect the gradation characteristics of soil. The following two gradation indexes are commonly used in engineering to evaluate the quality of soil gradation. Coefficient of uniformity is equal to d60 divided by d10, which represents the particle size. When the particle content less than a certain particle size accounts for 60% of the total soil weight, which is called the limited particle size. d10 represents the particle size. When the particle content less than a certain particle size accounts for 10% of the total soil weight, which is called the effective particle size. In engineering, the soil with Cu less than 5 is called the poorly graded soil, and the soil with Cu greater than 10 is called the well-graded soil. The shape of the particle size distribution curve of soil, especially to determine whether it is continuous or not, can be reflected by the curvature coefficient Cc. Cc is equal to the square of d30 divided by the product of d60 and d10. For well-graded soil, the pores between coarser particles are filled with finer particles. The coarse and fine particles are in good matching between particles. After filling well, it is easy to be compacted. Therefore, the soil has good compactness. The strength and stability of corresponding foundation are also in good condition, and the water permeability and compressibility are less. It can be used as filling material for subgrade dam or other civil engineering projects. Water in soil includes bound water and free water. Bound water refers to the water absorbed on the surface of soil particles under the attraction of electrical molecules, so that some water molecules and the surface of soil particles are firmly connected together. The bound water includes absorbed water and pellicular water. Generally, the surface of soil particles is negatively charged, and an electric field is formed around the soil particles. Water molecules within the range of the electric field of soil particles and cations in aqueous solution are absorbed on the surface of soil particles, forming polar water molecules that are arranged in an oriented manner. After being absorbed near the surface of soil particles, due to the strong electrostatic attraction, hydration ions and polar molecules can be firmly absorbed on the particle surface to form a fixed layer. The electrostatic attraction around the periphery of the fixed layer is relatively small, and the activity of hydration ions and polar water molecules is larger than that in the fixed layer. forming a diffusion layer. Free water. Water that exists in soil pores. The water outside the influence range of the electric field on the surface of particles is called free water. Free water is divided into gravity water and capillary water according to the different forces exerted on its movement. Gravity water. It is the water that is affected by gravity in soil pores and can flow freely. It has the common characteristics of general liquid water. It exists in permeable layer below the groundwater level and can transmit water pressure and generate buoyancy. Capillary water. It exists in the soil pores above the groundwater level due to the surface tension generated on the liquid surface. At the junction of water and air, the free water in the soil passes through the capillaries from the groundwater level. That is, the pores between soil particles penetrate, forming countless irregular capillaries. The free water gradually rises to form capillary water. We can distinguish several types of water from the figure. Soil gases. Soil gases exist in the pores of soil that are not occupied by water. They are often closed bubbles, isolated from the atmosphere in fine soil, which increases the elastic deformation of soil under the action of external force and decreases the water permeability. In organic soil, such as silt and peat, due to the decomposition of microorganisms, some combustible gases, such as hydrogen sulfide and methane, are accumulated in the soil, which makes the soil layer not compacted for a long time under the action of its own weight, resulting in a highly compressible soil layer. That's all for today's lesson. It is easy to see that the small soil has rich composition and great functions. Just like us individuals, we may seem insignificant, but as long as we are united and meticulous, we can also play a vital role in the group. Thanks for watching.